All right, so in section 2.5, we're going to be graphing rational functions and also solving rational equations. Now you've done all of these things in Algebra 2, and we've actually done some of them already this year. So this front page is just a kind of a review. Remember, for your domain, it's basically all real numbers except the x values that cause the denominator to be 0. The range, sometimes all real numbers, but sometimes it's everything except the horizontal asymptote, so we'll look at the graph to help us. Holes, you know, is when something cancels out. There's a hole there, and we're going to have to find the coordinate. So when there's a hole, we basically, to find the y value, you plug the x value where the hole is into the remaining part after the cancellation. Vertical asymptotes, so whatever's left in the denominator, it creates a vertical asymptote. And let's see, horizontal asymptote, you have your 3 rules. Degree of the numerator is smaller than the degree of the denominator, then you have y equals 0. If the degree of the numerator equals the degree of the denominator, you take your leading coefficients. And the degree on top is bigger than the bottom. That's where we're going to get our slant asymptote, which we will use long division for. And you got your x and your y intercepts. Okay? So let's take a look. So we're just going to do 2 of these because we've done a bunch already here and there. All right, so my first job is to factor everything. So when I factor the numerator here, I get x plus 3 and x minus 3. If I factor the denominator, let's see. Let me see, 5 here and 3 there. This will be a negative and a positive. All right. Yes. So you could also, you know, set up your x, right? 2 times negative 15 is negative 30. And then I get negative 1. So, of course, 6 and 5, you know, negative 6 plus 5. And then go ahead and do your factoring that way to get what I've gotten here. But we can see that the x minus 3 cancels. So there is going to be a hole, in fact, at x equals 3. So I'm going to start that off as 3, comma. So what's left after this cancellation is x plus 3 over 2x plus 5. So to get the rest of the hole, like where the hole is, I would plug 3 into this remaining problem. So I'm going to plug 3 in for x here and x there. So on top I get 6, on bottom I get 6 plus 5, so I get 11. So 6 over 11. So 3 and 6/11ths, so what's that, like right about here? There's a little hole right there, so we'll remember that. Okay, so let's go back to my domain. So my domain is all real numbers where x cannot be anything that makes the bottom 0. So x can't be 3, that's why we have a hole, and x can't be negative 5 over 2. So that's my horizontal asymptote, my vertical asymptote is at negative 2.5, right? So let's see, let's go ahead and draw that. Okay, so negative 2.5 right here. I guess I could have drawn a line there, but don't need to be fancy. Let me see if I can do that. So let me erase. All right, let you catch up, right? So I think if I'm trying to be fancy, I could just go like this. Draw a line, and I wanted it to be dotted. Oh well, whatever. You know what I'll do? I'll just erase some of it. Well, that erases too much of it. Anyway, sorry, I digress. Let me just draw it myself. All right, and let's go ahead and do our horizontal asymptote. Our x's, they match. Our x squareds, they match. And so for the horizontal asymptote, since these match, I'm going to take the numbers in front as 1/2. So y equals 1/2. All right, so my horizontal asymptote is going to be like right here. 1/2, and let's see, 6/11ths is bigger than 1/2, so it's going to slide right under the hole right there. All right. All right, range. We'll take care of the range soon after we finish graphing it, like on Desmos or your graphing calculator. Let's do the x-intercept and the y-intercept. So for the x-intercept, I am going to let the y value equal 0. So that's basically whenever the top equals 0. So I can use this reduced problem right here. So this is now y equals x plus 3 over 2x plus 5. So I want this to equal 0, right? And when does a fraction equal 0? Well, when the top equals 0. So what makes the top 0? negative 3. Negative 3 plus 3 would be 0. So negative 3. The y-intercept is when I let all the x's be 0. So you can do that in the original, or we can do it in this one right here. I think I'll just do it in the easy one. If I let all the x's be 0, I get 3/5. If I did it over here, I would get 9/15, which is also 3/5. All right, so let's mark this up. So negative 3, 0 is right there, and 0 and 3/5. Oof. So 0 and 3/5. 3/5 is bigger than 6/11, right? Yes, it is. So I'll just put it right there, even though it's like probably a little lower, but my red line's in the way. Okay, so from here, let's go and look at our picture, and we'll figure out the range. So I do have this already put into Desmos here. Whoopsie. No. All right, so there it is. And so you can see, you know, there's our intercept right there. That was my 3/5, right? And I can just basically see the rest of the picture. So I'm just going to draw my curves. There's my x-intercept over here. There it is right there. Okay. All right, so eyeball that picture. Now you can't see the hole, but if you do grab this point and like drag it along, if I can. I can't do it with my pencil there. All right. So let's draw it up. We got this coming down here, going across, a hole and skipping, and then this one's over here. So basically it looks like my, my y values, my range is everything except the horizontal asymptote. So it's all real numbers. Y never equals the horizontal asymptote, which is 1/2. All right, so next one. Sometimes you're going to have a slant asymptote. You haven't seen that before, but it's not going to be too bad. So slant asymptote is slanted, not horizontal. So when you have a slant asymptote in a problem, you're not going to have a horizontal asymptote because you can have one or the other. So basically what you do is you do long division to figure out your slant asymptote, and so I'm going to show you that. So I should try to factor everything. The top doesn't factor, but I do notice the bottom factors into x plus 1, All right, so the top is 2x to the third minus x plus 5. So that kind of helps me with my vertical asymptote. My vertical asymptote is going to be at x equals -1. Also my domain, all real numbers. X cannot be -1. The top is not going to factor, so there is no hole. Like I said, there's no horizontal asymptote either because we have a slant asymptote. Okay, the range we'll wait on. Let's figure out the x-intercept and the y-intercept. So the x-intercept is when the top equals 0. So we're gonna cheat a little bit. The top, I'm gonna look on Desmos for that. I'm not too worried about like figuring out the x-intercept, but if we wanted to, we could do something with that. But it's just too involved right here. So if the y-intercept is when the x equals 0, so if all these x's right here disappear, I get 5/1, so that would be 5. So we'll go ahead and put that there. Let's see. The slant asymptote. All right, so we're going to figure this out on Desmos later. Let's go ahead and draw a vertical asymptote at -1. Okay. All right, so the slant asymptote comes when you do long division on a problem. So you take your x squared plus 2x plus 1 and divide it into 2x to the third. X squared's missing, so plus 0x squared minus x plus 5. All right, so here we go. So to make x squared into 2x to the third, I would need a 2 and an x. So now multiply. 2x times x squared is 2x to the third. 2x times 2x is 4x squared. And 2x times 1 is 2x. Draw a line, subtract. This is gone. 0 minus 4 is -4 x squared. -1 minus 2 is -3x, and then plus 5. So now, to make x squared look like -4x squared, I need a -4. And this is basically all I have to do. When I go ahead and do this, -4x squared, -8x, and -4. I do my line, subtract. I'm not really interested in the remainder. -3 minus would be 5x, plus 9. There's my remainder. But what's happened here is this part right here, this is my slant asymptote. This equation is my slant asymptote, y equals 2x minus 4. Now you can have linear slant asymptotes, you can have, I guess, parabola slant asymptotes. It doesn't really make that much sense. But anyway, it's all about the difference between the numerator and the denominator. See how the degree is 1 higher than this? So that means I'm going to have a line for a slant asymptote. Okay, so if there is a difference of 2, then you're going to have a parabola for your asymptote. All right, but we're not going to get to that much detail there. All right, so let's graph this line, 2x minus 4. So y equals 2x minus 4, starts at negative 4, goes up 2 over 1, up 2 over 1, 2 over 1. Okay, so there's your asymptote. And let's get this one going down some. Okay, so the rest of this, I'm just going to go to Desmos and draw this up. So remember, these asymptotes come off there. Okay, so I have this entered into Desmos already. And it's going to look weird, but that's okay. So we see this blue thing is up at the top, kind of curling around my asymptote, because remember, my asymptote is, what, 2x minus 4? All right, so there's the asymptote, and my other asymptote was x equals negative 1. So you can put those on there too if you really want. All right, so you see how what's happening is the graph, it's kind of weird. Let me turn this, oh no, that's fine. It's not touching the purple line. It's crossing over the green one, but it's coming back towards it. So see how it's coming back towards the green thing there? So that's strange, but you can cross a slant asymptote. It's just telling you what your graph is going to at the end of the problem. All right, so it kind of, I'm going to draw this little top loop up there. So let's draw this one. So this one kind of comes through here and goes back around. Oops, let's make sure. Did it have an x-intercept? No, it didn't have an x-intercept there. All right, good. What was the x-intercept? Here it is. Ooh, negative 1.48. So I forgot, we're going to steal that there. All right, so right there. So this one, it comes up here. It comes down, and remember, it crosses over this, and it comes away from it, but then it gets back closer to it. I don't have a lot of space right there, but you can see from the picture, I just wanted to show you what a slant asymptote looks like, but you can see from the picture that it comes away from it, like right there, they intersect, but then it comes back to it, okay? This is a strange one, but you just draw what you see, it's fine. All right, so the last part here that we have to remember from Algebra 2 are solving equations. All right, so I'll try to go quickly here, and you can maybe break this video up if you need to break it up. But solving these equations. So with rational functions, you want to make sure that you kind of tell me like what you can't have x. So remember that the denominators can't be 0. So like this one here, x can never be 1. This one here, x can never be 1/2. So I'm just going to do that for all these problems here. All right, so I'm solving equations. These are answers that I will not accept. What would make the bottom 0 here would literally be 0 itself, and same thing for there. What would make the bottom 0 here would be 2 or 4. And this right here is just a combination of x minus 2 and x minus 4, so I don't need to worry about that. What would make this 0 would be negative 6, and what would make this 0 would be 0. And this guy is just a combination of those things, so we're good. All right, so you always want to like do that so that you can tell yourself, like, if you ever get those numbers as answers, those are going to be extraneous solutions. All right, so example 1 here, cross multiply. So it's crisscross. I got 3x times x minus 1 equals 4 times 2x minus 1. So let's do it. So 3x squared minus 3x equals 8x minus 4. So we got to pull everything to one side and factor, because I have x squared and x's and numbers. So I'm going to have 3x squared minus 11x plus 4. All right, let's see if we can factor that. So if you're doing your little puzzle, you got 12 here and negative 11. So it would be negative 12 and 1. And so you'd get x minus 12 and x plus 1, divide them both by 3. So you would get 3x plus 1, and you would also get x minus 4. So your answers are negative 1/3 and 4. And those are not any of these answers, so I will keep them both. Next one, same thing. I'll multiply here, I'll get 3x squared. Multiply here, I will get 4x times 5 plus x. So 3x squared equals 20x plus 4x squared. All right, I think I'll pull everything to the right. Take away 3x squared. Leaves me with x squared plus 20x equals 0. So let me factor out an x, and then I have x plus 20. All right, so my answers are 0, because that's what this guy produces, and then negative 20. So that is, oh, wait a minute. 0 is not acceptable, so I will cross him off. The only answer to this problem is negative 20. Okay. All right, for these ones down below, so I cannot cross multiply here. So I don't know if you remember, you had to kind of get a common denominator. So you know this right here is x minus 2 and x minus 4. So my common denominator is x minus 2 and x minus 4. So I have to kind of grow each fraction to be that. So this x minus 2 down here is going to need an x minus 4, and so that means I'm going to give an x minus 4 to the top. This next fraction is going to need an x minus 2, so that means I have to give an x minus 2 to the top. And once all the bottoms match, I can just get rid of them, and I can just leave the top. So on the left side, 4 is going to stay. This 3x is going to get the x minus 4, and then the 2 is going to get the x minus 2. And that way I can get rid of the bottom because they all match. I only need the tops to equal each other, because to make an equation equal, the sides have to be equal, the bottom's already equal, so why bother with it? So I got 4 equals 3x squared minus 12x plus 2x minus 4. So let's see, I got 3x squared minus 10x, and then bring that 4 over, minus 8. All right, so you can factor that however you like, but it factors into 3x and x. And let's see, 4 and 2, negative and plus. So I get x equals negative 2/3 and 4. And uh-oh, look right there, I can't keep the 4, so x equals negative 2/3 is my only answer. All right, over here, same idea. This x squared plus 6x is a combination of the other two, so x and x plus 6. So I'm going to have to give this guy an x to be fair, and I have to give this guy an x plus 6. So that means I have to give him an x plus 6. I have to give him an x. All right. All right, so the 12 is going to stay. And I got 2x right here, so that was easy, but I'm going to pay for it over here. I have to give an x minus 2 and x plus 6. That's annoying to me. So this is going to become x squared plus 6x minus 2x, so plus 4x, and then minus 12. All right, that wasn't that bad, but it was still annoying. So x squared, 2x and 6x, 4x make my 6x, and then that 12 is going to come over, I get minus 24. All right, 24, we got 6 and 4, 8 and 3, 12 and 2. Oh my goodness. Let me make sure I did everything right. 4 minus 12, I got 2x there, 12. Oh, poo, we need the quadratic formula. All right, that's going to be quick. Let's cross this off. So my answer is opposite of 6 is negative 6, plus or minus square root, we'll figure that out later, over 2 times 1, so 2. So let's do that old discriminant there. I need 6 squared, so 36 minus 4 times a is 1, and c is negative 24. All right, so I'm going to get my calculator. And if you're still awake, let's see, 36 minus 4 times 1 times negative 24. That comes out to 132. So that is not these answers, so I'm good to go with both of these answers. Let's just reduce this down a little bit. 132 divided by, how about 16? Nope. 132 divided by 4. Yep, 4 times 33. So that means that 132 can be written as 2 radical 33. So I got x equals negative 6 plus or minus 2 radical 3 all over 2. These three numbers all divide by 2. So my final answer is going to be x equals -3 plus or minus. The 2 is going to go away to a 1. And the bottom, the 2 goes away, so actually we'll just be done. All right. Okay, there we go. Yay. All right. So your homework is these 2 graphs and these 4 problems. And let me know if you have a